Imagine this. Scientists are using the immense magnetic fields of galaxy clusters to spy on distant black holes, all in the hopes of finding a particle so elusive it's been dubbed the ghost particle of the cosmos. Welcome to the wild world of axion hunting, where the stakes are as high as the challenges are daunting. This is a tale of cosmic extremes, where the heaviest structures in the universe, the clusters of galaxies, are a quadrillion times more massive than our sun. Meanwhile, the axion, a theoretical particle, is so light, it makes the lightest atom seem like a heavyweight champion. But here's where it gets controversial. What if these tiny, nearly massless particles are the key to unlocking the mystery of dark matter, which makes up about 80% of the universe's mass? And this is the part most people miss. Despite decades of searching, no one has definitively proven the existence of axions. Until now, perhaps. Researchers from the University of Copenhagen have cooked up a clever trick to get closer than ever to these phantom particles. Instead of relying on Earth-bound particle accelerators, like the one at CERN, they've turned to the cosmos itself, using it as a gigantic natural particle accelerator. Picture this. They're observing electromagnetic radiation streaming from the cores of distant, super-bright galaxies, each harboring a supermassive black hole at its center. As this radiation journeys through the colossal magnetic fields of galaxy clusters, some of it could theoretically transform into axions, leaving behind tiny random fluctuations in the data. But here's the kicker. Each signal is so faint, it's like trying to hear a whisper in a storm. So, the researchers got creative. They observed 32 supermassive black holes positioned behind galaxy clusters and combined the data from their observations. And what did they find? A pattern that resembles the signature of the elusive axion particle. Normally, the signal from such particles is unpredictable and appears as random noise, explains Oleg Ryshevsky, associate professor at the Niels Bohr Institute. But we realized that by combining data from many different sources, we had transformed all that noise into a clear, recognizable pattern. It shows up like a unique, step-like pattern that shows what this conversion could look like. We only see it as a hint of a signal in our data, but it is still very tantalizing and exciting. You could call it a cosmic whisper, now loud enough to hear. But is this pattern definitive proof of axions? Not quite, but it's a significant step forward. This method has greatly expanded our knowledge of axions, essentially mapping out a large area where they aren't, which narrows down the search. And this is just the beginning. While this experiment focused on gamma rays, the method can be applied to other types of radiation, like X-rays. We are so excited because it's not a one-time advancement, says postdoc Lydia Zadorozhna. This method allows us to go beyond previous experimental limits and has opened a new path to studying these elusive particles. The technique can be repeated by us, by other groups, across a broad range of masses and energies. That way, we can add more pieces to the puzzle of explaining dark matter. So, what do you think? Could this be the breakthrough we've been waiting for, or is it just another cosmic red herring? The debate is open, and we want to hear your thoughts. Share your opinions in the comments below.